Hi everyone, in this video I'm going to demonstrate and explain how we use Tinkercad to simulate an AC to DC power supply. We'll go through three main stages: rectification, filtering, and voltage regulation. In the first simulation, we build a center TAD full wave rectifier. Since Tinkercad doesn't have a transformer, we use two power supplies to simulate the transformer's secondary coil. We connect two diodes, D1 and D2, so that one conducts during the positive half cycle and the other during the negative half cycle. As a result, current flows in one direction through the load, giving us a full wave rectified output. Now let me explain how the diodes convert AC to DC using current flow direction. During the positive half cycle, the upper power supply, Vs1, is positive, and diode D1 is forward biased, allowing currents to flow through D1, the load resistor, and return through ground. Diode D2 is reverse biased, so no current flows through it. But during the negative half cycle, the lower power supply Vs2 becomes positive relative to ground. This time, diode D2 is forward biased and allows current to flow, again in the same direction through the load resistor, from D2 to the load and back to ground. D1 is now reverse biased and blocks current. So even through the voltage from the source alternate, the current through the load always flows in one direction. That's why the output is no longer AC, it becomes a pulsating DC. Next, we added a capacitor across the load. The capacitor charges when the voltage goes up, and discharges when the voltage drops, helping to smooth out the waveform. This reduces ripple and gives us a more stable DC output. Finally, we added a Zener diode in reverse direction. It starts conducting when the voltage exceeds its breakdown voltage, in our case, 3 volts. This allows it to clamp and regulate the output voltage. We also add a series resistor to protect the Zener diodes from overcurrent. After building the circuit, we click Start Simulation in Tinkercad. We can see the voltage waveform becoming smoother after each stage. Finally, the output voltage is stabilized at around 3.02 volts, which matches the Zener breakdown voltage. This proves our AC to DC power supply is working as expected. To sum up, we have successfully simulated an AC to DC power supply using three stages: rectification, filtering, and regulation. Tinkercad helps us visualize how each component works together to produce a clean, stable DC output. Thanks for watching.